Welcome back. Today we are going to find the correlation between two variables. So stick around. Okay, first of all, I do have the formula here. So we know the correlation is going to equals the covariance between x and y divided by the standard deviation of x and the standard deviation of y. And then at the bottom here, we have the formulas how to find the covariance, how to find the standard deviations and of x and of y. All right, so let's move this around, and what we're gonna do is we're gonna open a new Word document, Excel document. We're going to use Excel for this. Okay, I do have my Excel here. So let's assume that I do teach two classes. I do teach a mathematics class and a chemistry class. And I'm trying to figure out to see if there is a correlations between students getting good grade on math and getting a good grade on chemistry. And now I do have a large class and we have about 300 students. So it's a lot and we're just gonna do a sample. So what we're gonna do is we're gonna pick a sample of 20 students to figure out if there is a correlation. So let's type in here observation. That will be our number of observations that we have, 1, 2, and let's say we're gonna pick 20 students. That should give us plenty of data. Okay, so here we have math, and here we have the score that they got on chemistry, and then we just want to find out if there is a correlation, a student doing well on one test also doing well on the other. So let's type some numbers in here and see what we come up with. Let's make up some numbers. Let's do 9.9, 7.8, 8, 6.5, 7.9, 4.8, 9.9, 10, 9, 8, 7.5, 6.9, 8.8, 7.8, 8.7, 8.9, 9.5, 9.7, and this guy scored 810. And for chemistry, let's make up some numbers too. Let's see here. Let's assume this guy scored a 9, 9.8, 6, 7.5, 8, 9, 8.9, 8.8, 7.6, 6.9, 8.6, 7.9, 8.1, 8.3, 5.5. This guy didn't do too well, so let's say this did well, 9. This guy scored a 10. Let's do another 10, 8.8, oops, 8.8, and 8.7. Okay, so the first thing I need to do is I need to find my means. So I'm gonna write here means, and that way I know what I'm finding. And it's going to equals average of this data here. Okay. Okay, and so the mean for those 20 students on their math test was 8.43, and the mean for the students on chemistry is 8.32. So both of the means are somewhat similar. Now, this is just random data that I made up. So we don't know. We'll find out if there is correlation, right? So looking back at my formula, first thing I need to do is I need to find the covariance, which is this formula here, right? So it's going to be the sum of x minus x bar times y minus y bar. And because this is a sample data, we're going to use n minus 1. If it was the entire population, we will just do n. Okay, so what I am going to do here is let's see. this is going to be x minus x bar. Okay, so my x minus x bar is going to equal 9.9 minus my mean, which is this one here. That is my x bar. I'm going to put the dollar sign, so I'm telling Excel that the data on cell B22 is going to stay there. So I got that, and I just pull it down, and that is my x minus x bar. Okay, now I am going to need to find my y minus y bar. So I'm going to use this here, and I'm going to type y minus y bar. And all right, and same thing, this is going to equals my first observation minus my mean, and I need to use the dollar sign and the dollar signs right here. And I got all of my data now. Okay, so now I need to multiply my x minus x bar times my y for by the y bar. So here I'm going to need to multiply x minus x bar times y minus y bar. Okay, so what I'm going to do is I'm just going to type equals this times this. And now I'm just going to grab this and drop my columns, and I got this, right? So now I need to do the sum. Here's my formula again. So I need the sum of x minus x bar times y minus y bar. And in this case, I'm just going to go in here and I'm going to equal sum. Okay, and I'm just going to grab my data here. And that is my sum is 5.988. Okay. Now that I have that, I need to divide this. I need to divide this number right over here by n minus 1. So I do have 20 observations. Minus 1 is going to equals 19. So here is my covariance. Covariance is going to equals this number divided by 19. Okay, so my covariance is 0.3151. Remember, covariance just tells us is there is a relationship, but it doesn't tell us how strong that relationship is. So that's something that we discussed during the lecture. Okay, now what we need to do is looking at our formula. Let's go back on our formula. We need to find the standard deviation for x and the standard deviation for y. And here is our formula. It's going to be the sum of x minus x bar squared divided by n minus 1. So what we're going to do here is we are going to type x minus x bar, and then we need to square that. Okay, so we already have x minus x bar, so all we need to do is square that. So we're going to type in equals, and so we need to elevate that to the second power. So it's going to equals this to the second power. And that is my data there. All I gotta do is drop this down all the way up to here. And now we gotta do the same thing for y minus y bar. So y minus y bar Okay. So again, this is going to be simple. This is going to equals, here is my y minus y bar. And then I just need to elevate that to the second power. And that is my data. And then I just pull this down here and I got that. Okay, so to find my standard deviation, I need to get the sum of these. So all I have to do is grab this corner and pull it here, and this is my sum of x minus xy bar. What I have to do is divide that by 19. So this is going to equal this divided by n minus 1, which is 19. And I am going to do the same thing for this. This is going to equals my sum of this divided by 19. Okay, and now I need to do the square root of this, right? So it's going to be called square root of this and the square root of this, and this is my standard deviation. So I'm just going to write in here standard deviation. Okay, so now I have all the three parts that I need for to find my correlation. So I do have my covariance, I do have my standard deviation for x, my standard deviation for y. So all I gotta do is divide my covariance by the sx times sy. So sx minus, okay, so let's let's compute this times this. So this is going to equals times this number here, and that is my sx times xy. So now to find my relationship R is going to equals my covariance, which I have right here, divided by this number here. Or we can also do it this way. We can have that open parentheses, this times this. Okay, so my covariance, sorry, my correlation on this is 0.953. So based on what we learned, if the correlation is close to 0, that means it's not too strong. If it's closer to 1, it is really strong. And if it's closer to -1, it is strong but in the opposite directions. So closer to 1 is strong, moving on the right direction. Closer to -1 is strong on the opposite directions. On this case, I can say there is not a whole lot of correlation between getting a good grade on math and getting a good grade on chemistry. That means you could have a good grade on math, but not a good grade on chemistry, and vice versa. So there is not a whole relationship between those two. So as you guys can see, this one 9.9, 9 point, somewhat close, but yeah, 7.8 on math, 9.8. Here is 8 and 6. So we can say that the correlation is not too strong. Now, a shortcut for this will be to use the formula. So I can just type equals, and then what we're trying to find to do is the correlation. So just type core, and here is correl, and then I want to find the correlation between math, comma, and then the chemistry, and close my parentheses, and that should be the same number, and as you guys can see, it is. So again, this is how you will find the correlation between two different data. Again, we can use the formula. That's what I did in here. It took a little bit longer. Or you can have Excel do all the calculations in there. You type equals correl, pick your data, and Excel will do everything for you. All right. Thanks for watching.